Okay, we're good now. Today's stuff, 9.4, we're going to talk about compositions of isometries, and then it tells you what it is here. It means same distance. Okay, you know, like isometric things like that. So it says it's a transformation that preserves distance or length. And then here's stuff that we've already done. Translations, reflections, and rotations are all isometries. I always want to say isometries, but that's not right. And then it tells you that you can express them as compositions of reflections. Compositions means more than one. Okay? So in Theorem 9.1, it tells you that the composition of two or more isometries is an isometry. So it says if you've got two or more of these plural things, it becomes a singular. It's a weird little deal. And then down here it tells you there's only four kinds of isometries. You already know what a translation is. That just means it moves someplace in space. A rotation, it rotates around a point. A reflection, it reflects across some line. And now they've got this thing called a glide reflection, which means that it moves and then reflects. Okay? And then down here it tells you we're going to talk about glide reflections a little bit later. All right. Reflections across parallel lines. This is kind of a neat little deal because if you look at it, you can see that it almost takes back the same exact shape when it reflects multiple times, which should be obvious to you. It talks about a composition of reflections across two parallel lines is a translation because the shape really just moved. Okay? This little circle here between R sub M and R sub L, that is called a composition symbol, that little open circle. Okay? So what this is telling you is that you're going to reflect across M, and then you're going to reflect that across L. That's a composition. And that's going to give you your new shape. Notice that they did A double prime, B double prime, and C double prime because you did two different things. So the first reflection is going to be the A prime, B prime, C prime like you see here in the middle. And then the second reflection is going to be the A double prime, B double prime, and C double prime. So you're going to get some questions that say, once you do this, is it a translation, a reflection, or rotation? And you can see that once you do it twice, it's like taking the shape and then just moving the shape. That's a translation because it's not reflected anymore. Because once you reflect it and reflect it again, it's back the way it was originally. So that's what it's showing you here. Another way of writing composition is this thing down here below. This is the reflection of M of the reflection of L of triangle ABC. Okay, the big thing to notice on this too is the tricky part is notice which reflection takes place first. Which line is reflecting over first? L. Okay, when you do the composition, it always starts with the inside first, and the inside, if you look at the second way of writing it, is L. Okay, this is a reflection of M of the reflection of L of triangle ABC. So when you see those parentheses, it's kind of like saying the word of there. This is the composition of the reflection of M and the reflection of L, but we would read it as the reflection of M of the reflection of L of triangle ABC. So we always do the inside and work our way out. So don't reflect across M and then reflect across L. You're not going to be in the right spot. Although you would still be able to tell that it's a translation. You just wouldn't be translating at the right distance. So always start from the inside and work your way out. That's going to always be the case even when we do compositions of functions later on. Okay? Start on the inside and then work your way out. So we reflect across L first, and then we reflect across M to get our final spot. All right, now you've got reflections across intersecting lines. So this is going to be a little bit different. Okay? They show you here the composition. So this would be R of M of R of L of triangle ABC. So we are going to reflect it across L, line L first, and then we reflect it across line M like we did before. But now they're intersecting lines. So if you look at the picture, you can see that it flipped because it reflected, and then it flipped again because it reflected. But that whole entire shape, if you look at the shape and follow it around the path of this dashed red line, you can see that what it did is it rotated about the intersecting point. Okay? So when you double reflect over intersecting lines, it is going to be a rotation about the intersection. And so that'll be important to know, because if you know these things, if you know parallel lines, it's going to be a translation when you double reflect. Then when they ask the question and you see that you're reflecting twice across parallel lines, you're going to say, here's where it is, and it's a translation, because it's going to ask you that. If you see it reflecting twice over intersecting lines, you can say, okay, here's my new picture, and it rotated about whatever the point is where the intersection is. In this case, it rotates about point Q.
Pretend that you don't hear her.
Okay, glide reflection. Here's the new thing. Any composition of isometries can be represented by either reflection, translation, rotation, or glide reflection, which you have not learned yet. Here it tells you the definition of a glide reflection. It's the composition of a translation and a reflection. So you move it, and then you reflect it. Okay? And then it gives you these paw prints right here so that you can see it. So it says you can map a left paw print onto a right paw print with a glide reflection. Right? So if you wanted to do the distance like or even a person walking, okay? You would take the distance that they step and then reflect it, and it would make their left shoe print look like a right shoe print. See what I'm saying? Okay, we're going to find the image of each letter after the transformation. And then it wants to know, is the resulting transformation a translation or a rotation? We should be able to answer that question before we even do the reflections. And then it wants us to describe the distance and direction. It says for a translation, describe the distance and direction. And for a rotation, they want us to tell the center of rotation and the angle of rotation. So you're going to have to use a protractor possibly for that one. That one might be a little bit more challenging. For number 1 here, really all you're going to need is a ruler. Okay? Distance and direction. We know we're going to go so many units down, right, on number 1. So if I took this, I have a rotation tool. If I take this, let's see, capture here. Let me capture it. Let's see if it'll stay.
Awesome. He slides like that.
Okay. Let's cut this object here.
Why can you do anything he wants to do?
He did like an adjective or whatever.
You guys realize this is recording, right?
Yeah. All right. So we're going to take this here. We're going to measure the distance. Let's say I just use a ruler, okay? So we won't be able to see it on the smart board, but you'll get to see it because I'm doing it in front of you. If we measured this, we'll use centimeters, okay? And we reflect it, and it's about 6 centimeters. Okay, so we have to go about 6 centimeters from this line. So we will take the object, and we will put it.
Is it bigger?
Don't worry, we'll fix it.
What's the dot?
Okay. Don't worry about the dot.
Ah, it's too small. The green one?
It's too small now.
There's the dot.
Okay, it doesn't have to be
It's too big.
Okay.
Now that's perfect.
It's got to be 6 centimeters from the line. Well, what happens now is it kind of puts us right on the line. Almost. It's right above the line, actually. So it's about, I'm measuring, looks like it's about half a centimeter or so. And so we'll take the next shape, which I know it's too big. We'll fix it. It's the same size now. And so it is right there. Okay? So we're the same distance away. So since we said that measuring it up on the board is about 6 centimeters there, and it really was about 1 centimeter, so I need to move this X up. If it's 6 centimeters down, okay, to get to the line, then another 6 centimeters down to make our new shape, and then we go down 1 centimeter, and then we go down another centimeter. Will that work if we add all those up?
I'm confused.
We need to figure out the direction. When we know the direction, it's going down. It's reflecting down, right? 180 degrees. We're not doing degrees, so we're just saying down. So we need to do the distance. So we have to measure, right? The problem is you can't just measure the distance between the lines, because now we're measuring from the bottom to the line and then from the line to the top, right?
Oh, okay.
So we have to measure the whole entire distance from the top to the top all the way down to the bottom.
Wouldn't it be 6 then? If it was 6 from L to X, then wouldn't it be 6 from L to the other X?
Here's what you've got. You just got to measure it from the top all the way to the top. It's real easy if you've got. Where's that yardstick?
Wait till like the bottom of the first one to the top of the second.
Well, you can do that if you want to do it in components. But wouldn't it be much easier just to get the ruler out and measure from the top to the top?
Wait, why the top?
That's what I just said. That's not what you just said.
What did you just
What
say?
did you just say?
They're from the top, one to the top of the other.
13 inches. So you say 13 inches. 13, 13 inches down. Okay? And we know it's a translation, right?
How do you measure it from the top of the first one? It's like, oh, it's
We have to measure how it translates.
it's like the whole thing goes.
Yeah.
So the top to the bottom or the top to the top?
Top to the top. Why did I say 13? It looks like 11.
That's 11.
Looks like 11.
You were at the 2 before.
Oh, that's 2. Okay. So it's 11 inches. Okay? Just measure from the top to top. It's a simple ruler problem on that. Now, this one becomes a little bit more challenging when you're doing this T reflection. And it's going to be harder to do on the smart board. But what you're going to do first, we got to reflect it across L. So we need to measure the distance, and then we need to mark our new spots. Okay? And so what you're going to do is on this T, how many points are there? 3 points, right? And so what we need to do is measure them at a perpendicular line to L. So you're going to have to use your protractor and or just the edge of a paper, right? Because you know your paper is going to be a right angle. And you can measure it down. So we're going to just kind of guesstimate it here just because, for time's sake. But you'll get the idea. So if we measure, just like we did before, the reflection first, it's about there. What do you think? Can we say 2? A little less than 2?
Coach Crusher, where did your tissue box go? Whoa, you just.
Sorry, I was touching the.
It's not on his desk.
Okay? So that's going to be the bottom of our T. And then we can measure again all these other sides. I'm trying to do it without touching the board with the.
Wait. How do you know, like, how much to write to do?
No, it's got to be 90 degrees. We're just reflecting right
So it
now.
has to be 90 degrees.
Yeah. Okay, here's going to be the right edge of the T. And then this is going to be.
It doesn't look long enough.
The knowledge long enough? Let's see.
Like the bottom, it's probably not at 90 degrees.
It probably isn't. Let's try it here. I think that's about right, don't you think?
Well, I think it just looks different because you're like thinking of a line between two because it has
Yeah. Let's do this. Let's do this other one first, and we'll see. Remember, it's reflecting all the way across. So this top left point of the T is going to be the farthest point away from the line, so it should still be the farthest point away from the line. So it's about 4.5. Well, I don't know if I'm at a right angle. Is that a right angle right there?
Yeah.
Okay. So it's going to be about right here. Okay. Okay. Except for I can't really draw straight. Okay, there's your T reflected. And now what you have to do is do that again around M. And so you're going to do the same thing. Kind of measure your distance and go. Right? So we're going to approximate it here. Okay?
Wouldn't it have? Oh, I have a question.
Now we should know what this thing is doing. It's doing what? And actually it's kind of off because it should be down like this.
Why should it be? It like doesn't turn. It just slides down.
It should be like that. Okay? It's just hard with the smart board. It'd be easier if we had a protractor that would take forever. What point is this rotating around?
V.
It's rotating around V. And then what we would have to do is we would have to measure that angle. Now, do you have to measure all 3 of the points to find the angle? You should only have to measure 1 because shouldn't it be the same angle for all 3? So this will be easier for you on a paper with the protractor to do. Okay. Okay, so yesterday, this is where we left off. And the one thing that's new that we haven't done, but luckily it's not all that difficult, is the glide reflection image. And it's the same thing. We know this open circle means what? composition. And we know that when we do composition, we work from the inside to the out, kind of like the song that you see in basketball once in a while. All right, so when we read this, we're going to reflect across the y-axis the translation of the triangle. That's how you would read it. So we have to do the translation of the triangle first, and then we were going to reflect it. So the translation says that we're going to move the triangle how?
3 to the right.
We're going to move it 3 to the right. First number is your x-coordinate, second number is your y-coordinate. The y is 0, so we're not moving it up or down, we're just moving the whole entire shape to the right. So we're going to take all of these points, we'll use green here.
Draw the lines.
Oh, the axis?
Yeah.
Yeah, the axis is, here's your y-axis right
Cross
here.
this and you are.
Okay. And then this is your x-axis right here. Makes it a little bit thicker for you to see. Okay. Translate first. All we're doing is taking everything, all the points, moving it 3 to the right. D, 1, 2, 3. Here's your D prime. L is right here. We move it 1, 2, 3. So L is now where M was. That's going to be your L prime. And M is now 1, 2, 3 right here. And that's going to be your M prime. And you've got yourself a triangle.
It looks the
Okay.
exact same.
And it should.
Now you have to reflect it.
Okay. Now what we need to do is we need to reflect it across the y-axis. So the easiest one is going to be which one?
And
M, because where's it going to go?
right.
It's going to stay where it's at because it's on the line that we're reflecting across. So now this becomes, right here is your M double prime. Okay, when we're just add a prime mark when we do it. We'll do D next. D is how far away from the y-axis? 2. So we go 2 away from the y-axis here, and that's where our new D double prime is going to be. L prime is how far away from the y-axis? 3. So we go 1, 2, 3 away, and now this becomes L double prime. And so now
It looks the
we've
exact
got our
same.
glide reflection. Okay? We translated the image, and then we reflected the image. Glide reflection. Okay? Over here, we're doing the same thing. We're going to translate it, the triangle DML, -1, which means which direction are we going? Left 1. And then we're going to reflect over y equals 1. So we'll make that line. The y equals 1 line is right. Y equals 1. I don't
Wouldn't
know.
it be like this?
Yeah, tell me how it's going to go.
Like this?
Which way should it go?
Horizontal.
Yeah,
Horizontal.
right? Remember when you're doing the y equals or the x equals, it's always really opposite of what the axis line is going, right? Because if y equals 1, it has to always be 1. So it would be, where's the y-axis? 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, whatever. So we're going to be reflecting it across this line right here. We'll call this the y equals 1 line. Okay? And then what we need to do first, before we decide to reflect it, is we need to translate it first because we're working from the inside out. So we're moving every point down 1, you said. So, or left 1, I mean. Left 1 is going to be here, D prime, here, L prime, and here, M prime. So here is your new,
Wait, so do you look for the translation first?
you always, no. Okay, you don't always do the translation first, but you always do the inside first. So since the translation is there, that's what we're doing first. Okay? So remember, it's whatever, it's kind of counterintuitive because you're not going left to right, you're working from the inside out.
Pressure. What is that little circle?
On this glide reflection, do you guys understand why one of the numbers is 0? In this case, the y's were both 0 on the glide reflection. Remember when we looked at the definition, it says that it's going to glide one direction. Okay? Now, it could glide diagonally, but then you would probably have a diagonal reflection line as well. So it makes it a little bit easier on you. So yeah, you want to make sure you work from the inside out. It sometimes could it work if you did it the wrong way? Yes. If everything kind of just worked out that way, it could, but that's not going to be the case all the time, so we want to make sure we don't do that. All right, the next thing we have to do is reflect this across this y equals 1 line. And so all we're going to do is look at the distance away again. So if we start with L is how far away from the line? 1, so we go 1 the other direction. That's going to be your L double prime. M is how far away? 1. That goes right here. That's your M double prime. And D is how far away? 4. 1, 2, 3, 4. And this becomes your D double prime, and so here is your glide reflection. Okay, so you've got a problem where they want you to graph a line. And then they want you to graph the image after a reflection, first across the L1 and then across L2. So this is kind of what we did at the beginning. It wants to know if the resulting transformation is a translation or a rotation. We've already talked about this before. If it is a translation, you have to describe which direction and distance. If it's a rotation, you got to tell whether the center of what the center of rotation is, and then the angle of rotation. We know. So let's recap then. We know it's going to be a translation if L1 and L2 are what? What kind of lines? Remember this? Parallel. If they're parallel and you reflect across one line and reflect across the other, then we know it's a translation because you flipped it and then you flipped it back to how it looked before. Okay? So we know if the lines are parallel, we know for a fact it's going to be a translation. If it's going to be a rotation, we know that the lines have to be what? Not necessarily perpendicular, but they have to be some intersecting lines. They could be perpendicular, but they have to be intersecting. All right, so now, if you look at this, x equals 1 is going to be a vertical line right there. X equals 1, and y equals 1 is going to be, y equals -1 is going to be right here. Okay, so this is y equals -1. So before we even start doing the problem, can we tell if it's going to be a translation or a rotation?
Yeah.
Yeah, we know it's going to be a what?
Rotation.
We already know it's going to be a rotation. Okay? And it's going to rotate about whatever we want to call this. What do you guys want to call this point right here in the middle? Q, sure.
Where is it? Letter in the alphabet.
Okay.
Where's letter in the word?
Q. So we know it's going to rotate about Q. So now let's plot these points and draw the line. First thing we've got is -3, 4. So -3, 4, I got to make sure I go from the right line. 1, 2, 3, 1, 2, 3, 4. This is your A. And then you've got -1, 0, which is right here. This is your B. And there's your line. We need to reflect it across L1, which is x equals 1, which is this guy right here, this red line, which is kind of nice because it's a straight line. It makes it real easy for us to figure out what's going to go across. So A is how far away? How far away is it? 4, right? 1, 2, 3, 4. So this will be our A prime.
Wait, which one are you supposed to go from?
The red line. We're going across x equals 1 first. Okay? And then B is how far away? 2. 1, 2. This is going to be B prime, and there's your line. Okay? And then we need to reflect that line across L2, which is y equals -1, which is this black line here. So how far away is A from this line here?
5.
5. There's your A double prime. And B is how far away?
1.
There's your B double prime, unless I did something.
Doesn't that look like a translation?
It does, kind of. Okay. Is it? I mean, could it be a translation? Could it be both?
Is it because it's 90 degrees?
We'll have to see. Yeah. So, if you wanted to see the slope of this line, this first initial line, the rise is 1, 2, 3, 4 over -2. So it's -2 slope, right? If you go down here, it's 1, 2, 3, 4 over -2. It's a -2 slope, right? So then it's going to be pretty important for us to realize that when they're perpendicular lines, it's going to be a rotation, because what's happening is you're taking the shape. You can almost see it. You can almost see the rotation happening, right? Is it 180 degrees rotation? Is it on the same line?
No.
180 degrees? Well, here's Q right here.
I don't think it is.
So,
But it kind of looks like it.
but it is a rotation. Could we use the compass, draw the lines, and see what we get? We should probably do it, right? So let's do that. Let's use the compass. I'm going to steal this one over here. Okay, I'm going to try to draw straight lines. Is that right? Is it all right if I take
Oh,
this?
yeah.
Okay, good. So
I'll say compass.
I said compass again. Protractor. All day long yesterday I called it a compass. All right, so we're going to draw some lines. We'll use, what color should we use here?
Green.
Can you
Green.
change the color to make it different?
That would have been nice, huh?
Oh, do the rainbow one.
No, that's all right, so we got a straight line here, and we're going to go to B, so we have a straight line here.
You're just trying to make a straight line, or you measure?
No, well, I'm trying to do a straight edge because what we have to do is we have to measure this thing. Actually, what is that going to be? What do you guys think that is? I think it is 180 degrees.
So isn't it translation then?
Is it?
Yeah.
Or is it? I'm asking you, could it be both?
Yeah?
Yes.
In this case, because of the perpendicular lines,
So whenever it's perpendicular lines, it's a translation and a rotation?
I would still call it a rotation just based on definition. Because the definition of the intersecting lines was telling us that. You know why this really worked out? Is because we're dealing with a line and not a triangle or some other crazy shape too.
Yeah.
Kind of
So
makes a
it
big
wouldn't
difference on it.
exactly be- It wouldn't be a translation because the A goes from the
B and A are
top to the
backwards.
bottom.
Right. Do you see what Casey's saying?
Yeah.
What happens if we draw a line from A to A?
It's not the same.
It's not going to be the same line. Because here what happens is you go up 4 and to the left 2, right? And here what happens is you go 1, 2, 3, 4 to the left, to the right 2. So what's happened with the A is it's kind of switched the sides on it. Remember, if you take this whole thing and move it, A would have to be on top and B would have to be on the bottom. Does that make sense?
Yeah.
So is A on the top? It's the same line. And if all we cared about was the distance of the line, it would be the same line. But since A is up here at the top, then it would have to be up at the top down here on the blue line too. And it's not. And so now the rotation was really nice because of the perpendicular lines. If we measure this right here, it's going to be what kind of a line? Straight line. So when you're writing down what the rotation is, you would say, is it a big R or a little r? Little r. What goes next?
Oh, the point.
Angle.
180,
180,
comma, Q.
comma Q. Right? Because that's the point that you're rotating around. Do you guys remember what goes out here?
Line 80.
Okay? I was lenient on this. This is what I really wanted to see. Okay? So, intersecting lines, rotation, and you guys knew it right from the beginning. As soon as you drew your lines that you were going to reflect across, you knew it can't be translation because those have to be parallel. So at least you have that part right, and then you just have to work it out. It's not too bad when they just give you 2 points. Actually, if they give you 3 points and they make the lines vertical and horizontal, it shouldn't be that difficult for you all to do. So make sure that we're able to get this taken care of.